If you're looking to pick up the ZV-E10 Mark II for long-form video recording like live streaming, video podcasting, or long-form interviews, you might be concerned about your camera overheating.
Regarding overheating,
internal temperature too high,
heat problems.
The camera overheated every 20 to 25 minutes.
But how big of an issue is this really? Well, I ran over 20 different tests with this camera in different configurations for long-form recording, and the results were pretty surprising.
You gotta just press record.
Hi everyone, Craig Pruitt with Think Media. So today we have the ZV-E10 Mark II that we're doing some overheating and recording tests for. Now, don't be too overwhelmed. There's a lot here, there's a lot to work through, but I'll explain it as simply and clearly as I can. Now, with this camera, we recorded everything for these tests in my indoor studio environment. So everything was shot. Most of it was actually shot right here at this second workstation that I have, or over here at this main workstation that I have. And my studio sits right around 71 or 72 degrees Fahrenheit, which is 22 degrees Celsius for our friends who are not in the United States, which is a pretty typical indoor shooting temperature. Now, when I was recording, the screen was also always flipped out away from the body. So I'd never had it like tucked right here against the body, and this just helps with heat. So it was always flipped out either facing me or away from me like this. A note here about these tests are that obviously your results are going to vary. These are just my results in my studio. And of course, especially if you film outdoors often, like a long form outdoor sort of recording or podcast, or if you're a wedding filmmaker or something like that, and you need long form record times outside, this camera will perform much worse, especially in direct sunlight, or if you're in like 80 or 90 degree weather, it's gonna be much worse. So just note that all these tests are indoor environments. Last note real quick is that we did add chapter markers to this video so that you can skip to a specific section that pertains mostly to you. So the first kind of test that we have is just the kind of normal internal battery. We were recording to an SD card. So just a normal camera setup configuration, just like this, right? So you have the battery and you just hit record, right? And how long can this thing record? So we did quite a few tests here. The main thing I want to note here is that the camera actually recorded for as long as the battery had power in every scenario but two. And those two scenarios were when we were recording in 4K at 60 frames per second in both the XAVC-S codec, which is a little bit more compressed, and the XAVC-SI codec, which is the highest 4K codec that this camera has. Now, there was an instance here in 4K at 24 frames per second in the highest quality codec XAVC-SI, where the camera ran for an hour and 26 minutes, but we did get an overheat warning indicator around 50 minutes or so. So just so you're aware, at 4K and the higher resolution codecs like XAVC-SI, at 24 frames per second and also 30 FPS, you'll probably get some overheat warning indicators, and also the battery performance just drops off when you shoot an XAVC-SI as opposed to the more compressed XAVC-S codec. But you can pause or screenshot this graph if you want to use this as a reference later. So our second type of test was with the internal battery still in the camera, but then we added a USB-C power cable to the camera to hopefully extend the record time, right? So this USB-C cable would then prevent the battery from dying, hopefully increasing your overall runtime. But in our case, this did not actually happen at all. And in every instance in 4K, the camera actually overheated when we were sending USB-C power to the camera. I did highlight in yellow one of these lines here, which was at 4K 24 XAVC-S. This was a weird test in which it actually performed worse than the highest quality codec. And there's a variety of reasons this could happen. The time of day that we did the test could have been a little bit warmer, could have been later in the day, but I just thought that was really interesting that it's not consistent necessarily, but depending on the codec that you're filming, there's a lot of variables here, but I just want you to see for the most part that in 4K, if you add the USB-C power delivery, this camera is going to overheat. And then on the 1080p side with this method at 24 frames per second and 60 frames per second in some different codecs, we never experienced any overheat warning or any indicator, and both of these tests ran longer than 3 hours. So for our next type of test, we still kept the internal battery in the camera, but then we connected the USB-C cable that we were sending power to, connected that to our computer to use this as a streaming source. So this is how you would live stream with this camera via a USB-C cable. And for this test, we did not record internally. So this is just sending the signal to our camera and using this as a webcam with the USB-C feature. And we only ran 3 tests here. And with our first test in 4K, the camera also overheated at an hour and 28 minutes in the XAVC-S codec. And then again with 1080p, we ran tests at 30 frames and 60 frames per second. And a note here, you're actually limited with what frame rates you could stream with with the USB-C feature. So that's why there's so few tests here. There's a few frame rates that we didn't test, but these are the 3 frame rates that most people would actually use: 4K 30 and 1080p 30 and 60. The 1080p side, both of those tests ran for over 3 hours, which is actually pretty encouraging. So now we wanted to see if we could increase our overall runtime by using a dummy battery instead of a standard NPF Z100 Sony battery. So a dummy battery, again, is just kind of a hollow battery replica with some contact points. And then the cable runs into a power source, like a power adapter that you can then plug into a wall. So you're getting continuous battery power from a wall source. And then that power supply is what builds up a little bit more of the heat and then takes some of that heat away from the camera and moves it into the power supply. Theoretically, this helps increase your overall runtime. So we wanted to do this test, and here are those results on screen. And it indeed actually did increase our overall runtime in several frame rates and resolutions. So at 4K 24 and 30 in the higher codec XAVC-SI. It did increase the overall runtime for both of those frame rates, and we did get overheat warning indicators on screen, but our card filled up before the camera overheated, and we were using a 256 gigabyte SD card from ProGrade here. Now when we switch the camera into XAVC-S 4K, which is going to give you a little bit longer record time on the same SD card because it's a more compressed codec, so you get more space on your SD card, which is cool. But when we ran this test, around 3 hours and 10 minutes is when the camera overheated. So I'd imagine the same results would have been true in XAVC-SI. It would not have gone much longer than 2 to 2.5 hours in the XAVC-SI codec. And then in 1080p at 24 and 60, it ran for 3+ hours. And so our next setup I think is ideal for streamers. This is using the dummy battery again, so you're drawing heat away from the internals and moving it external, and then using an HDMI capture card to capture your video signal rather than the USB-C cable. So with these results, we were able to get 3 hours and 2 minutes at 4K 30. And then when we bumped that codec up to SI in 4K 30, you got 2 hours and 24 minutes before the camera overheated. So you're not going to get much longer than 2 to 3 hours of the camera being even just on, not even just recording, but the camera being on in the 4K resolution. And this is the optimal way to do this right here. If you want the longest record time and run time and power on time with this camera, the dummy battery and HDMI capture is the way to do it, but you're not gonna get much more than 3 hours, at least in a 71, 72 degree studio like this. I highlighted one of these green on the screen right here because I think, in my opinion, this is the best format to choose for live streaming. 1080p at 30 frames per second, XAVC-S as your codec choice. We ran this test for over 4 hours and it ran continuous, and it just never showed us any sign that the camera was going to overheat. And then we just wanted to see if we could hack this camera a little bit and use a combination of modalities by using the dummy battery for power and then the USB-C port for streaming, but then selecting the power delivery set to off so it's not sending any power to the camera. It's just utilizing that USB-C port for streaming. And the results, I mean, they were fine. At 4K, the camera still overheated at around an hour. And then at 1080p, we did a test at 60 FPS and it ran for over 3 hours. So technically you could use this as well in 1080p at even 60 frames per second or 30, and the camera shouldn't overheat on you, hopefully. So I know that's a lot of information, so let's break it down into some key takeaways. The first being, if you can, just always use a dummy battery for long form video recording. So if you're podcasting, if you're live streaming, the dummy battery is going to be the best way to extend the runtime with the ZV-E10 Mark II. The second thing you can do is just kind of avoid the USB-C port because this is the main problem. This is going to generate more and more heat, especially if you have it set to power delivery on and it's sending power to the camera. That's the worst case scenario for the ZV-E10 Mark II, and you're going to experience the quickest overheating when the USB-C port is being used. The third thing would be 1080p is going to be your friend for live streaming. So this is not a great 4K streaming camera really at all. I wouldn't really use it for 4K streaming. So if you're okay streaming and 1080p still, this is going to be a pretty good camera for 1080p live streaming. The next tip would be XAVC-S is going to perform much better than XAVC-SI in terms of longer record time. So if you're trying to reach that 2 or 3 hour mark, XAVC-S is going to be a better option for you. Also, no matter what you do, 4K 60 frames per second is going to overheat. And every single test I ran in every configuration, 4K 60 was a huge problem for recording. Even in some instances, it was like 7 or 8 minutes in which the camera would overheat. Even just the camera being on in 4K 60 would generate lots of heat. So If you want to use this camera for 4K 60 FPS recording, just do it in really short bursts for B-roll and don't really use it for any other purpose. And then the final note I'll add here, which is actually pretty promising, is that in every instance where the camera died or overheated, I didn't lose the video file. So the file was not corrupted and I was able to plug in that SD card to my computer and grab the file off the camera just fine. So that's encouraging. If your camera does die or overheat, it's okay in the sense that you won't lose the file, but pretty frustrating that we have to deal with overheating even in 2024. I hope you found this video helpful as you consider if the ZV-E10 Mark II is the right camera for you, especially in long form recording scenarios. If you do want to know how to maximize the video potential of this camera and how to set it up best for video, go ahead and click or tap the screen right here so you can check that out, and we'll see you in the next one.